Hi there, today I'm going to show you how you can access data from multiple NetCDF files in one Python script. We're going to look at the CTD data from Nansen Legacy project, mostly in the Northern Barents Sea, that you can see here. I'm showing you here the data from one cruise plotted on a map on the SIOS data access portal. These data have been published using parent-child relationships, so there's lots of NetCDF files, each containing a single depth profile. That's each point here. So if we scroll down, we can access one of those, for example, the top one. These data are published with the Norwegian Marine Data Center, and each depth profile comes with its own DOI that you can see here, and a recommended citation that you can include in your reference list if you're using these data in your own publication. But if you use most or all of the depth profiles from this cruise in your publication, there's also a parent page, which has its own DOI and a recommended citation, so you don't have to cite each station individually. Now, I'm interested in the children in this video, so I'm going to go back here. These data are available via OPeNDAP, and if you press this link here, you'll download the NetCDF file. But we don't want to do that in this case. There are 60-something NetCDF files for this cruise, and that would be tedious. So instead, what we're going to do is we're going to copy this link here, paste this into our browser, and we're going to append to the end .html. And this takes us to the user interface for this NetCDF file. This is an OPeNDAP server data access form. So if you wanted to, you could download the data as a NetCDF file, as an ASCII file, just in a text file format. And you can even take a subset of the data by just selecting the variables that you're interested in. But in this case, what we want to do is access all of the NetCDF files in Python using a single script. Now, returning to this page, OPeNDAP makes it possible for you to access the data and load them into Python without actually downloading the data onto your own computer. And you can do that by copying this link with a .nc suffix. And I'm going to open up Visual Studio where I'm going to work today. I will import xarray as xr. I'm going to create an object, xrds, which is going to be equal to xr.openDataset. And then in quotation marks, I'm just going to paste that URL that I've just taken from OPeNDAP, and I'm going to print it below so we can see what it's doing. If I run this, you can see in the terminal below the data have been loaded in. So now what we want to do is loop through every single one of these OPeNDAP links for all of the datasets in our data collection. So we're going to edit this URL at the top, and if we just remove the actual NetCDF file here and hit return, you can see on this page all the NetCDF files from this cruise. And actually, if you go up one further, like this, you can see all the cruises that we have these NetCDF files for. Now, to do this, we need to import a new module called citing. So we can do that in our terminal using pip install citing, which of course takes a few minutes. We're going to remove these lines here. Then we're going to do from citing.catalog import TDS catalog. Now, if I hover over this TDS catalog, you can see that this allows us to parse information from a THREDDS client catalog. So basically, THREDDS provides an infrastructure for publishing and organizing scientific data, while OPeNDAP facilitates the access of the data over the internet. So if I go back to this page, you can think of this like the human interface to the data, but if you append to this catalog.xml, you have a machine interface to the data in XML format. Now, if you haven't looked at an XML file before, this might look a bit confusing, but basically you can see that there's some information at the top, and then each of these groups, which I can open up and close, corresponds to different depth profiles or different NetCDF files. And within this, you can see the URL path to each of the NetCDF files. So we're going to use TDS catalog to loop through and access each of these. So I'm going to take this URL with a catalog.xml at the end. I'm going to create a variable catalog URL, make it equal to that URL. I can do catalog equals TDS catalog, and then in brackets I can use this catalog URL that we've just created. And then below that I'm going to write datasets equals catalog dot datasets, and I'm going to print this datasets object below. So how does that look? Well, what we can see if I open up the terminal is we have a list of all the different datasets. And note that this is just the file name, not the full URL. So let's close this. Now, the full URL that we can use is a combination of this file name and also the URL that we have here, but without this catalog.xml at the end. So I'm going to change this. I'm going to call this base URL. I'm going to remove this catalog.xml here, and I'll create catalog URL equals base URL plus catalog.xml. I'll just test that works and I haven't made any typos. So here we're creating the catalog URL as a concatenation of this and this. But this way we have this base URL, but we can append each of these file names too. So I'm going to remove this print, and now I'm going to loop through each of the datasets in this list. So we can do for dataset in datasets, and now for each iteration of this for loop, we'll have a single item from this list. I'm going to write profile URL equals base URL plus dataset, because each of these datasets is a single depth profile. And now we can use the code we had earlier. So xrds equals xr.open dataset profile URL, and then let's print something from this file to show that it's working. So let's do xrds.attributes to access the global attributes, and I know this has an attribute called time coverage start, and if I run this, you can see in the terminal that that attribute has been printed for each dataset in turn. Now I'm going to abort this because we want to do something a little bit more useful. So now we've shown we can access and open all of the datasets in just a few lines of code. What if we now want to combine them all together, for example into a pandas data frame that we can save into a CSV file or an Excel file, for example? So we're going to go back a few steps here. I'm going to comment all of this out, and I'm going to show you quickly how you can access the data from one file into a pandas data frame. So let's just pick one URL from one of the datasets. So something like this. Let's load this in. So xrds equals xr.open dataset and the URL. I'm going to call this profile URL actually for consistency with the code above. And what we're going to do is have a look at this dataset. So I'll just print it here. If I expand this, we have a lot of different variables, but in this case, what I'm going to do is just access the temperature and the salinity data. And because we're accessing data from a lot of different locations, we're going to need something to distinguish one data set for the next. So if I minimize this, we can do xrds.attributes to show the global attributes and open this again. This isn't the nicest way of looking at this. So what we can do instead is do for key val in xrds.attributes.items, because this is a Python dictionary. Now we can do print key val, and let's put a line in between as well. And run this. If I open this, we can now see each of the attributes and the value. So if I go up, the information I'm looking for is this geospatial lat min, geospatial lat max. They're the same because this is a depth profile. And we also have the longitude equivalent. If you're wondering where these attributes are from, this is from the attribute convention for data discovery, and you can see that this has been referred to here. So basically this is a controlled vocabulary of terms that tells you which global attributes you should be including, and also some information about how you should populate each of those attributes. So to create a data frame from this, we're going to use df for our data frame object equals xrds, and in double square brackets, because we're accessing a list of variables, we're going to have this temp and psal for temperature and salinity. And if I do dot to data frame and I print the data frame below and run this, you can now see in the terminal we have a data frame with pressure, temperature and salinity. Pressure being the coordinate variable associated with these variables. So now we've got to put this code that I'm going to uncomment again together with this code. So I can remove these two lines here. We don't need to print this attribute. And we're going to move this, converting the data to a data frame within this for loop. And what I'm going to do is create a list of data frames. So I can do that above. Go data frames list equals an empty list. And for each iteration within this for loop, I can do data frames list dot append and append the data frame to the list. We'll print that so we can see what we're doing. This does take some time to run. Obviously, I'm cutting out the runtime to make this video less boring. And there we go, we have a list of data frames. And each of them has the same 3 column headers. Now, we might want to add some more information to each data frame to help us distinguish one from the other. So we can do that here. For example, df latitude equals xrds dot attributes for the global attribute, and geospatial lat min, which we looked at earlier. With some copying and pasting, we can do the same for longitude, and we can also do the same for time. I'm going to run this again and wait. Of course, you don't have to run this every time if you don't want to, but I want to show you how things are progressing. So when that's finished, I can open this up and we can see that these columns have been included. Now, you could write each of these data frames out individually into separate CSV files, but what we really want to do is combine all of these data frames together. So we can do that by taking this data frames list and creating a master data frame, master df equals pd for pandas, which reminds me we need to import pandas now, pandas as pd, dot concat to concatenate them together, and data frames list. And while we're at this, we're going to write this out, so we can do master df dot to CSV. We can enter a file name for our CSV file. This might be the absolute file path for you. I'm just going to save it to the same location, so I can use a relative file path or just the file name. So CTD data multiple profiles dot CSV. And I don't want to include the index column from this, so I can do index equals false. If I run this now, I don't know why this line is faded out. Let me know in the comments if you do. And it's finished, and a new file has popped up here. We can have a look at that, and we can see all the data from all the different profiles. Now, you might not want it like this in one long table, You might prefer to take just one of your data variables, for example, like this temperature, and have a single column for each depth profile. So we can do that by just making some small tweaks to the code. We can remove all of this. And in this case, instead of writing all the data frames to a list, I'm going to create a dictionary called profile data using the little curly brackets. We're going to write each data frame to a different key within that dictionary. We're going to need something to distinguish one profile from another, so we can use, for example, the timestamp we can get from xrds.attributes to get the global attributes, and time coverage start. And then we can write this data frame to the dictionary with profile data, and we can use this timestamp as our key. So each profile will be written to a different key. And we only need a single data variable here, so we can remove salinity, and we also then therefore only need a single set of square brackets. We actually don't want to write a data frame in this case, we want to write a series, and we can do that by including the variable name here, or more precisely, including the column header. To show you why I'm doing that, I'm going to show you a separate piece of code. Here we're just reading in a single depth profile, creating a data frame, and we're doing the same here and creating a series. And then I'm going to print it out and print out what the type of object is. So we'll have a look at that in our terminal. And if I open this up, you can see with the data frame, we have the pressure and temperature, and the type is data frame, and this is confirmation that this is a series. Now, the difference is a data frame is a collection of series, and therefore the data frame can have lots of different columns potentially. But if we're going to later combine the data from multiple NetCDF files into a single master data frame, it's easier if we're using individual series and combining those into a data frame rather than trying to combine different data frames. At least that's how I've set the code up to work in this example. So if I minimize this again, and we go back to the code, I can then create a master data frame and make that equal to a pandas data frame. This is a new data frame object. And we just want to include each of these series. So we can do that by taking our dictionary, profile data, and accessing just the values, not the keys. So just this bit, not the timestamp. So what this should do is create a single data frame by combining all the series together. Print this below so we can have a look. So if we open this up, this looks like this. But in this case, we have 62 rows and 3,370 columns. But we want this the other way around. We want each depth profile to be a separate column. That's an easy fix. We just have to do .transpose. And while we're at it, why don't we write the timestamps that we've saved as the keys in the dictionary as the column headers. So we can do that by doing master df.columns and make that equal to profile data dot keys. And then instead of printing this, let's actually write this to a file. So master df dot to CSV. We'll call it CTD data multiple profiles separate columns dot CSV. That's a bit of a mouthful, but that'll do. So when that's finished, we can have a look, and we can see we have many more columns here with the timestamps listed as the headers. If we want to have the latitude and the longitude in the headers as well, we can do that. So what we're going to do is, as well as taking the timestamp, we're going to take the latitude and also the longitude. And then we're going to write these three things to a tuple. So we're going to call this tuple key, and we create a couple using round brackets. Then we can write timestamp comma latitude, comma longitude. And we're going to use this tuple object called key as the key for our dictionary. We have to make some small adjustments down here as well. Instead of writing the keys to the columns, what we're going to do is first create an index. So most data frames have a single index, but in this case we're going to create a multi-index. So we can write index equals pd.multi-index.from tuples, and then we can write our profile data dot keys. We need to assign some names for these indexes as well, so we can do names equals, and it has to be in the same order as we've assigned them here, so timestamp, latitude and longitude. We're going to assign this in here. So if we do index equals index. So remember, with this code, we're creating a data frame where each NetCDF file or each depth profile is an individual row in the data frame. So we're assigning the index to each row. So whilst this is the index that we're assigning here, this will later become the column headers as we transpose the data frame. So let's run this for one last time. So when that's finished, we can look at the CSV file that we've created, and we can see that the timestamp, latitude and longitude have been written on separate rows at the top. So I think I'm going to leave it there now. Of course, there's lots of different things you could do once you've opened up each of the data files. You could write each one to a separate CSV file. You could take just a subset of the data, for example, by doing something like if longitude is less than 31.5, for example, then you could do all the same again, and then only these data will be written to your data frame. You could create and write out different plots for each one of the files, or you could even write the data from all of the files, or perhaps a subset of the files, to a single plot. But of course, how you do that is going to vary very much depending on your requirements. I've actually included an example of how you can plot data from multiple files together in a single plot, and you can find that in the Jupyter book that accompanies this video. There's a link to that down in the description. If you would like me to do more videos where I show you how to plot data from multiple NetCDF files, just let me know down in the comments. If you liked this video, like and subscribe, and I'll see you next time. Thanks very much for watching.